Hello friends, welcome to the course of data science, and we are seeing machine learning. Now after the completion of supervised machine learning algorithms, I am going to show you the unsupervised machine learning algorithms here. There are two different ways I'll be showing the unsupervised learning here. Unsupervised learning does not have the direct predictions. It's used to find the pattern in the data, as well as is to find the grouping, is the relationship among the data, and based on that the labels will be assigned. So first and most important prime category of the unsupervised learning is clustering kind of algorithms. In clustering, there are many different kind of algorithms available, like K-means, hierarchical clustering, Gaussian mixture, DB scan. Out of all, two most popularly used clustering techniques are K-means clustering and hierarchical clustering. So in this video, I'll be showing the K-means clustering methods, and after that we are going to see the remaining clustering methods here. Before that, let's understand the unsupervised learning flow. Unsupervised learning is just like we are going to have the historical data, we pre-process it, maybe it's required, and then we are going to find the patterns and rule inside. What pattern and rules are there? Based on that, we are going to create the we are finding these patterns, and after that we are going to do the predictions for a new data. Prediction is possible, so when next time new entry comes, in which patterns it fits, that we'll find, and based on that it will be classified in a particular class there. Now the first method of using the unsupervised learning is called as clustering. What is that? The key objective is to identify distinct groups called as clusters based on some similarity notion within a given data set. What similarity that the internal data is containing, based on that similarity the distinct groups are created, that we call as clusters. The cluster analysis originates from the area of anthropology and psychology in so many years ago. The most popularly used clustering techniques are K-means, that is what we call as divisive clustering, and second is hierarchical, that's called as agglomerative clustering technique. Now let's see the K-means clustering. The key objective of K-means algorithm is to organize data into clusters such that there is high intra-cluster similarity and low intra-cluster similarity. So if two clusters are there, so they are dissimilar much, okay, and if multiple elements within a cluster or group are having high intra-cluster similarity there, okay. So an item will only belong to a single cluster, not the several. That is, it generates a specific number of disjoint non-hierarchical clusters. They are not overlapping, they are not connected to each other. So K-means uses a strategy called as divide and conquer method. It's a classic example of expectation and maximization kind of algorithm, which makes up of two different steps. So its category, the strategy that this algorithm follow, is called as expectation and maximizations. The first step is known as expectation and used to find the expected point associated with the cluster. Okay, expected point is identified. In second step is known as maximization. It is used to improve the estimation of cluster using the knowledge from the first step. So what expectation is that expectation can be achieved with the help of second phase, that's called as maximization. These two steps are processed repeatedly until the convergence has reached. So let's see how it does that. Now I am having a data, so I plotted this data in a two-dimensional plane. So it will be easy to show the clustering. That's why I am taken two-dimensional space over here. See, so one feature on this side, x1, and second and x2. So this data I plotted, and I want three distinct groups from this particular data. So after clustering, I'll get the group something like this. So these elements are similar features, these elements are again of similar features, and these red elements are of similar features. So based on similarity notion, we are going to create the groups within this data. That's what we call as clustering. So this is input to the algorithm, and this is the output of all the clustering algorithms there. So your clustering algorithms will find this input and output respectively by this particular mechanism. But how is perform these operations? So let's check it, how EM algorithm actually behaves. Now there are four different steps in which algorithm will perform the operations. Our algorithm works follows, as assuming we have inputs x1, x2, x3, till xn, and value of k. K means how many elements you want, how many groups or clusters you want. That's what the value of k is. First of all, step number one, pick k random points as cluster center called as centroids. So once the data is plotted, we have k random points. They are almost have equidistance placed over that particular plane, and they are called as centroids. Centroids, we consider them as the center points of your cluster. That's why the term centroid is referred. Then second, let's take one by one element from your data set, that is xith element, and check which is the nearest cluster, which is the nearest centroid to that particular point is. First element centroid, next element, second element, third element, which is the nearest centroid. Okay, that will be found. And after finding the nearest centroid, that particular point will go in that cluster and find the new cluster center by taking the average of the assigned points. Okay, whatever points are now there in the cluster, take the average of all and a new centroid will be formed after this. Okay, and then repeat step number 2 and step number 3 until none of the cluster assignment changes. So all the elements which we are using for assigning into the clusters, once they are ended, then steps will be ended. That's how the algorithm will work. Okay, so let's see with the help of a graphical representation of it. This is what we call as E, expectation, and this is called as the maximization. So let's see how it works. For example, these are the points that we are having in our data set. We are plotted in a two-dimensional plane based on first feature x1, second feature x2. Okay, so first of all, we'll take three centroids, C1, C2 and C3. They are almost equidistant on that particular plane, and let's take one by one point into that cluster. For example, point number 1 is this. So which centroid is near to this? So you can compare finding Euclidean distance method, which is the nearest centroid. So C3, so it will go inside C3 and then C3 will change, it will average over here. The next point is this, so it which is the nearest centroid, C2, so it will go in this cluster. This nearest point is this, for this nearest point is this, for this nearest point is this. Okay, in this way one by one point from the data set is taken and will be identified which is the nearest centroid of it, and in that particular cluster the point will go, and after that centroid will change by averaging all the elements present inside the respective clusters. Okay, so one by one step it will go on running and centroid will go on changing. So that's why I mentioned over here, will change and again go maximize, then maximize means point will be plotted into the cluster and then change the centroid, again point in the cluster, then change the centroid, again point cluster, change the centroid. When points are finished, they are completed, then our maximization step will be over, and at the end I'll have centroid C1 here, C3 here and C2 here. So these are the initial centroids and these are the recalculated centroids, and at the end we'll have a cluster like this where centroid will be the center point of the respective clusters. So here C1, C2 and C3, three clusters are formed, and that we can visualize by our visualization methods available in the scikit-learn. So this is how the algorithm flows, and very simply, easily it creates the clusters. So basically clusters number are given randomized fashion, maybe starting from 0, 1, 2, 3, 4 onwards. So till k-1 the points will be assigned to it. So Euclidean distance formula is used over here to calculate the distance. Okay, so this is how the simple mechanism is used to have a particular point inside the cluster, and based on similarity notion it is performing this operation. So this approach we called as a divisive clustering method. Okay, and the second method is called as agglomerative, that we'll see in the next video. Now, what are the limitations that this contains? K-means clustering needs the number of clusters to be specified in advance. Just like k neighbors are there, we need to specify that k value in advance. Here also we have to specify the k value in advance, how many clusters you want out of it. But still there, two standard methods are used to find what will be the ideal value of k will be present, should be present, means which k will perfectly create the clustering within this data. The K-means has a problem when sizes are of different size, clusters are of different size, densities and non-globular shapes. Okay, so that's why it may create the problem in this particular cases, because it uses Euclidean distance formula to calculate the distance. That's fine. Presence of outlier can skew the results. Outliers means some of the points which does not follow the crowd's criteria, so they are far away from the original group, that we call as outliers. Generally K-means is also used to find the outliers. So one of the video after unsupervised learning, I'll show how K-means can be used to find the outliers also. Now, where the K-means clustering can be applied, so it's widely used for many applications like image segmentation, finding different things inside the images, okay, or clustering the gene segmentation data, news article clustering, like based on the words present inside the news, we can find what kind of news is that, whether it's political news, crime news, sports news, local news, or any other are. Clustering languages. So if you are given the words, different words or different scripts, so you can identify what are the similarity are there. So these words belongs to which particular language, spoken language. Species clustering, finding species based on their common features, so which animals are in which species, that we can find. And anomaly detections, one more applications in outlier detection technique is just similar to anomaly detection. So anomalies means some discrepancies are there in the data, can be found with the help of anomaly detection technique and K-means clustering here. Okay, so that's it. That's what the K-means clustering is, the basic theoretical introduction to K-means. Now let's apply our algorithm. So in this algorithm, I'm going to show you how to apply the K-means. Basically, unsupervised learning like K-means don't require much pre-processing operations, which is directly a direct method is present there. But I'll be showing two statistical method by which you can find ideal value of K, and most important, visualizing it, predicting it, as well as showing the groups and the centroids in this data. That's all that we can see over here. Now let's assume a data set. So data set name is mall_customers.csv. What's the meaning of this? This information, this is the information of clients that subscribes to the membership card. So whenever you visit a particular mall, so they give a membership card to you, and on that membership card some information about the customers are maintained. They maintain the purchase history, and the score is also, score depends upon the income and the number of times in week the show of the mall, total expenses in the mall. So look at the data set. This is the customer ID, gender, age of the customer, annual income, and spending score. Spending score means how much the particular customer spends per month. Based on that, these customer the spending score is identified. Annual income of the particular customers in $1,000, and age of the customer and gender of the customers here. Now I can so there is no any output variable, these are the input variables only. Now I want to form 5, 6, 7, 10, 20, whatever, or 3 number of groups out of it. I don't know what's the value of K present there. Why it's required, that I will show after the end of the clustering there. So I want K number of groups from this particular data, because there is no any output variable. I will have similarity notions of them, and based on that I'll assign a cluster number to them. So that's my task. So that I will decide the strategies to apply, means for example, I want to market a particular product. So I want to do the marketing of this particular product. So which group of people, which kind of people can purchase this? Okay, so that I have to identify. So which kind of people are similar, their groups I will form, and which are dissimilar, that it's not required to have a relationship between them. So that groups will decide, that group, the data within the group will have ability to purchase a particular product. So my task will be drastically reduced by this particular mechanism. That's why I'm going to create the groups within this particular data. So let's see, let's apply and open the data set for our algorithms here. So let's see, my data set is mall customers. You downloaded from again UCI machine learning repository, and the MITU's dataset repository also, it's available there. You can download from there. Let's see this dataset which I have shown on the slide. Same dataset is present here also. Okay, so before actually using this data inside the code, I want to show this in two-dimensional plane. So my first question is, which are the two most important feature that will create the clusters correctly, means affecting parameters. Okay, so out of almost all excluding customer ID, all can affect the output, means they can create the perfect clustering, gender also, age also, annual income also, and spending score also. But I want to visualize this data in the form of a two-dimensional plane. So only two most affecting features are required. Annual income and spending score are, according to my point of view, these two are the most important features present here. Most important, age and gender are also good, they are also having effect in the output, but I want to show in the two-dimensional plane. That's why I'll take only annual income and the spending score. Only two features I'll take, and based on that the clusters will be formed. Yeah, so these two features I'll take, and then I'll show the clustering of this data, how many K will be required, that will show you. So let's go ahead, let's read the file. So import the pandas first, and my file which is present in my current working directory, pd.read_csv mall_customers.csv, right? Check it out. So in this file, total 200 customers information is stored, and the columns which you have seen there, customer ID, gender, age, annual income, and spending score. Okay, out of all, the column number 3 and 4 I required in the data set. X input variable, I don't have Y, output variables are not there. So what we'll do, age, annual income and spending score, this is column number 3 and column number 4, only that I'm extracting from here, data.ilog, all the rows, and column number 3 and 4 exactly. Check it out. So I have extracted that data, x.head, first 5 entries I have extracted from the given data set like this, annual income and spending score. Okay, now no much pre-processing are required. So if it is data is in string format, then I require to convert it, else it will not be. Now my algorithm is present inside the cluster, sklearn.cluster import KMeans. So it will import the KMeans class from the cluster package. Okay, it's present there directly. I can import it, and now to create the object, like CLS is my object of it, KMeans, I'm applying number of cluster 3, just randomly I have given that. Randomly I'm giving the cluster 3, I want 3 clusters out of it, random state type kept as 0, and after that I'll apply cls.fit predict. Okay, so basically it generate the labels out of it. You can check these labels. See, so cluster object dot fit predict. So whatever algorithm I explained, same algorithm will get applied on it for all the 200 entries here. Okay, so it's applied, and it's predicting the labels. See the labels 0, 1 and 2. These labels are predicted by the algorithms here. So these are saved inside the object also, and I can save like y is equal to something like this in this way. Okay, it's directly possible, but I don't know what is the ideal value of clusters. So 3 clusters are formed, I can create it, I can directly use it. There is no any other method to do the operations of clustering here on KMeans, but I need to find what is the ideal value of K. Okay, so how many clusters are required? There are 2 commonly used methods to determine the ideal number of clusters in possible in KMeans. First method is elbow, and second method we call as the Sealout method. Out of it, elbow method is very popularly used. It's a graphical visualization method, and Sealout is the statistical method by which you can find ideal value of K. See the elbow method. Elbow method, what it does, first of all, it computes the sum of squared error, that is SSE, for some values of K like 2, 4, 6, 8, and SSE is defined as the sum of square distances between each member of the cluster and its centroid. Okay, some square distance of every member. Okay, so that is, if you plot K against SSE, you will see that the error decreases as K get larger. This is because when the number of clusters increases, they should be smaller, so distortion is also smaller. The idea of elbow method is to choose the K at which SSE decreases abruptly. This produces an elbow effect on the graph. Let's revise the SSE again. We'll go back now. For example, all of these points are there in this. So I'm having currently value of K equal to 3. So in this case, 3 clusters are formed. Okay, what is SSE? So let's see the distance of this point from the centroid. Okay, it's square. This distance square, 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 everyone's distance. From this also distance square, this distance square, this distance square, and addition of all. This is called as sum squared error. Okay, sum squared error. So value of K equal to 3, sum squared error will be something like 20,000, 40,000 if you add them together. Getting, so sum squared error. And one more observation, if you change the value of K, sum squared error will decrease. Remember why? Because the number of points in the cluster will also get reduced. That's why the sum squared error will decrease, and the point which are closest to the centroid only they will remain. So that distance will also get decreased. That's why sum squared error will also get decreased. Now just consider there are 20 points inside it, and I want 20 clusters. So every point will belong to every one cluster. What is SSE? 0. Correct. So it means that when value of K increases, sum squared error decreases. Okay, but what's the difference in that? So what I'll do, I'll have a plot like this. On this plane I am having the value of k, the number of clusters, and this side I will have the value of sum squared error. So you can see if k is equal to 1, this is not the example connected to current example here, this is just an I just taken one of the plot, and by which I am showing how exactly elbow will be used here. Okay, now k equal to 1, I am having almost 4000, then k2 it reduces 2000, 3000 somewhat, then 2000, then again decreasing. As you go on increasing the value of k, it creates a elbow. Okay, check it out where the elbow is, on point number 6 here. So in this case, which is shown here, in this case k is equal to 6 is the value that elbow method has selected. So from this point the rate of decreasing SSE had reduced drastically, and it creates an elbow effect here. Okay, and go on reading. So for this case, which is shown on this plot, value of k equal to 6, this is elbow effect that is created, SSE against the number of clusters. So let's do that one for our case. If I want to find the elbow, so I must know the SSE first, and I will plot SSE against the number of clusters, and then will show where I'll get the elbow, and that will be the ideal value of k present. So let's go for our example. Now how to find SSE? So once you feed the data, there is an parameter attribute called as inertia underscore. This inertia underscore parameter contain the SSE for k equal to 3. For this case, whatever k value is present, inertia will change. If I print the inertia here, see the sum squared error for k equal to 3 is this. Okay, 1,06,348 when k is equal to, okay, if I make it 6, check, reduce 37,000 inertia is there when n is equal to k is equal to 6. If you go to 10 clusters, see this 19,000. So as you increase the number of clusters, sum squared error has reduced. So sum squared error is automatically calculated by your algorithm, and it is stored inside the variable called as inertia. Fine. So this is how we can calculate. Now I want to plot. Now how to plot? So let's take a range. So I'll be taking a range of elements here. See. So first of all, I'm creating one array list here. SSE is equal to empty square brackets, and I'll iterate my for loop for value of k in range 1 to 15. Okay, it will start from 1, will reach till 15. Okay, and this value I'll provide to KMeans. KMeans number of clusters equal to that k. Fine. Random set equal to 0. This is fixed, but only this value I'm changing. Whatever k I'm getting over here, this k value I'm putting it here, and for that k I am applying cls.fit predict x. So the value will be predicted here for SSE. For labels, and once prediction is done, then inside the CLS whatever the inertia is present, that is sum squared error is present, this sum squared error I am appending to the SSE list. Okay, for every value of k, when k1 inertia, then 2's inertia, 3, 4, 5, 6, 7, 8, 9 till 15, all of their inertia will be appended at the end of this SSE list. Okay, so that's what I have done here. Let's execute it. Yeah, execute it. Okay, so before actually plotting, I'll show one values what SSE is actually containing. Check it out. This is the SSE present. Sum squared error which I calculated for every value of k is printed. See, it started from 2,69,000 for value of 1, then 2, 3, 4, 5, 6. You can check this graph, it is decreasing. But from which point the rate of decreasing is becomes low. That is what elbow point I want to plot. So number of clusters, that is this range, against this SSE I want to plot. So let's import matplotlib.pyplot as plt, and we'll have a line plot for this particular data. How to do? So on x side I'll have the value of k, on y side I'll have sum squared error, and when I plot it, see on x side value of k which is starting from 1 to 15, range is 116, and y side I have sum squared error. So length of this list and this list is same, and marker I'm putting a dot there. So we'll have a dotted lines present over there. Not dotted lines, means the actual position will have a dot and they are connected by a line. Okay, so value of k against the SSE I'm plotting. Got the plot. Yes, see the plot over here. So creating an elbow effect again, and value of k is equal to 5. So we have elbow over here, this point. Okay, from this point the rate of decreasing has become slow, and if you keep it as a hand, we can consider this as a elbow. Okay, 5 is the elbow point, and that's the ideal value of k for our cases. Okay, so we can cross verify it. Cross verify means we can apply the second method in our case. That's what we call as the that's what we call as the Sealout method. Yes, Sealout analysis. Now Sealout is a statistical analysis. Now it is the way to measure how close each point in the cluster is to the point in its neighboring clusters. It is the way to find out the optimal value of k during k-means clustering. Now what's the meaning of it? Sealout values lies in the range of -1 to 1. Okay, the value of +1 indicates that the sample is far away from its neighboring cluster. Okay, +1 indicates that the sample is far away from its neighboring cluster and very close to the cluster it is assigned. Very close to the cluster it is assigned. And similarly, negative value, that is -1, indicates the point is close to its neighboring cluster than the cluster it is assigned. Okay, and the value 0 means it is the boundary of distance between two clusters. Value of +1 is the idea and -1 is the least presence, hence the highest value is better than the cluster's configuration. Okay, so I'll go back again and let's revise it. What's meant by Sealout score? Let's consider. So when this point is closest to this centroid, okay, its Sealout score will be 0.8, almost close, and this is almost near to this neighbor than this particular point here. Okay, this neighbor, so maybe it is -0.8. okay, so almost equal to -1. So it is far away from this centroid. Okay, if I consider this centroid, not this one, then only closest and the farthest. Okay, so based on that, so how many points in the cluster are far will decrease the Sealout score, and how many points are very close to the centroid will increase the Sealout score. Okay, that's what the statistical method actually tells us. Now let's take an example. In the data, let's define a of I to be the mean distance of point I with respect to all other points to the cluster assigned A. We interpret a of I as how well the point is assigned to the cluster. Smaller value is better than the assignment. Okay, now how it is assigned? So A is the first cluster and B the second cluster. So distance from first cluster and second cluster. For example, I want to find Sealout score of a point S of I. How it is calculated? S of I is equal to distance from the neighboring cluster minus distance from the own cluster divided by max of A of I, B of I. Now remember, it is exactly on the boundary. We will get a 0 over here. Okay, max of A of I, B of I. If I subtract them, so I'll have these points are same, the 0 will be present, divided by any number will be 0, and it's almost close, will reach this point towards 1, and almost far away it will have this value negative because this number will be less than this number, so it will have the negative values. So this formula is used to find the Sealout score for the respective data. Now we are not going to find the Sealout score by using this formula. We are having a function, and with the help of that function Sealout score is calculated. So Sealout score is addition of all the points Sealout score finally. Okay, now the value of k which is having highest Sealout score, means highest value in positive basically, that value of k is the ideal value for identifying the k that we can find. The highest value of Sealout score should be present. So let's do Sealout score. So Sealout score can be found with the help of a function in the matrix package. It's called as Sealout underscore score. This one. Okay, so I'm taking one list over here, SILH equal to empty list, and I'll be starting from 2 to 16. Let's use from 1 to 16, not 2 to 16, 1 to 16. CLS is equal to k means number of clusters k, random state. Okay, predict it, and now while finding the Sealout score, the predicted labels by the algorithm, that labels you have to pass as parameter to Sealout score function. These are the inputs and these are the labels, means input and output variables are identified. So input and outputs. So based on this input and output, we are finding the Sealout score for the value of k, and that Sealout score we are appending at the end of this. Yeah, for similar way we have done for elbow where SSE is found. Here we are finding the Sealout score. Let's run this. Error. So error is something different. Check it out. The number of labels is 1, valid values are 2 to n samples. That's it. So what's the error? The error is this. See how Sealout score is calculated. Its own value, its own distance and neighboring cluster distance. Now if value of k equal to 1, there will not be any neighboring cluster present, so that this function will not work. That's why the error is present. It means that Sealout score is not possible for value k equal to 1. So let's start from 2 to 16. Done. Almost done. Yeah, perfect. And now Sealout score for value of k equal to 16 is 15 is calculated, and now we are going to plot the same again, but I'll be using the bar chart here. On x side I'll have value of k, and on y side I'll have the Sealout score. Okay, so x side I'm having value of k, we start from 2 to 15, and on y side I'll have the Sealout score, that is SILH, which is appended from here. Sealout score is appended, and I'll plot, and then we'll see where the highest bar is there. Check it out, where the highest bar is present. Yeah, 5, again 5. See this, at 5th position we have the highest bar present there. Getting this? So Sealout is also telling highest value of k or ideal value of k is 5. Here highest bar. How to find this value? So visualization we have seen that, but if you want to find it, I'll be using this method. The maximum of Sealout, where it's present in the index of Sealout, okay, that I am finding plus 2. Why plus 2? Because your indexing is starting from 2 here, 0th and 1 element is not present, that's why I want to add plus 2 there. Fine. Okay, if you don't give that, it will show 0, 1, 2 and 3, because first index will start from 0 there, but actually our index start from 2. So 2, 3, 4, 5. That's what I am getting out of it. 5 is the ideal value of k. So for both the methods, by using elbow method and Sealout method, we have identified the ideal value of k is equal to 5. So let's apply the 5 clusters there and create the object. It's decided finally. So let's create it. K means number of clusters 5, random state 0. So these are the labels. This is the cluster formed, and after that labels is equal to clf.fit predict. So fit predict is just to apply the algorithm and predict the labels for the respective data separately. Okay, that's what we have done. And if I want to print these labels, see all labels are printed, all 200 entries. First is 3, 1, 3, 1, 3, 1, 3, 1, then 0, 0, 0 are there, then 2, 0, 2, 4, 2, 4, 2, 4, like. So in this way, the clusters are assigned the labels, that is output variable we can call. So label is the output variable which is assigned there, and all 5 labels are assigned. And if you see how many labels are assigned there, you can see set of labels. So 0, 1, 2, 3, 4. Total 5 clusters are formed. And if you want to see the inertia, that is 4, 4, 4, 4, 8 for value of k equal to 5. These are the labels. So here I am saving this value in labels, plus these values are stored inside the object also. How? Check this. cls.labels underscore will contain the similar values again. One more important thing you have to remember, that if you are doing this on your system, these labels may be different. Okay, 3131 you may have 242424 or 010101 or 121212, like, but their sequence is in that directions. Their numbering system may be different. Okay, number may be different, but clustering is perfect. Okay, so number may be different. And again, inside the same object, we are having one more parameter called as cluster underscore centers. So it stores the centers. As we have seen, we have created 5 groups inside it. So it means that 5 cluster centers will be there. Is that? Check it out. See, these are the cluster centers. So this is what we have: annual income, this is spending score. Annual income and the spending scores are given here. So these are the top 5 cluster centers for the 5 cluster generated over there. Getting? Now after that, let's see one more mechanism here. Now I want to visualize it. This is most important part, whether clustering is done correctly or not. I want to visualize. So how to visualize that? Let's see. First of all, I created a plot here with the resolution 16:9. On y side I will have annual income plotted. On x side I will have the okay, let's see this one. Okay, on okay, this is not required. Okay, same. So x side I will have annual income, y side I will have the spending score. Okay, and then using a scatter plot, I will plot all this data here. How? So in X, I am having two columns. Out of that first column, I am putting on X axis, and the second column, that is column number 1, I am plotting on the Y axis, that is annual income on X axis and spending score on Y axis, and I am plotting a scatter plot over here. So let's see this. Okay, so this is unclustered data. I have not applied the cluster labels yet. Okay, so cluster labels are not assigned, but clusters are formed. See, on here annual income on this side and spending score on this side. Based on that, this actual original data I am plotted. Now I want to show the colors to this particular clusters. See how what to do. So here in cluster, I am having one parameter called as C, color parameter, and this to C I will apply the labels. It means that, see, 200 values are present here in sequence. For every point, it will take the particular number from here, and that number's color will be assigned. Maybe it's having 1 2 1 2 1 2. So those who are assigned with the same label, they will have the same color. The points which have same label will have the same color from here. Okay, so C is equal to labels which I have assigned. So whatever 5 values are there, that only 5 values will revolve inside this 200, and wherever the points which belong to same cluster will assign the same colors from the labels list. And let's see this. See, so one cluster here, one cluster here, one cluster here, one cluster here, one cluster is here. Getting this? So this is how clustering is created. And now on this point, I want to plot the centroids of them. So let's take these centroids, centers into the centers variable. 5 centers are there, and these 5 centers I will plot with the help of the scatter plot. PLT dot scatter from these centers, first point, that is 0th column in X axis and 1st column in the Y axis. Okay, this is how I have taken here. Size of that point I am keeping 200, so it will be more highlighted than the original points here, and color I am putting red there. So let's take it. See, these are the centroids of the clusters, which are shown by the dark red color. Fine. So this is the way by which you do the clustering. Perfectly clustered data is shown on the screen here. Centroids are shown, and what's our implications from this particular data. Now let's my implications are, let's see what are the implications. Okay, so implications are, now these are the customers, correct? So this group of customers are having annual income and spending score both are less. This group of customers are having high annual income but low spending score. This group of people are having low annual income and high spending score. This group of people are having high spending score, high annual income, correct? And what's this? Yes, you are right, these are middle class. Their annual income and spending score both are average. Okay, now marketing team will group out this data and will use this data for any particular operation. So they know that now these kind of people are same, their mentality is same, their mentality is same, their mentality is same, like, so based on their mentality, so the product will be given to them, and more useful perfect marketing will be used. This is part of business intelligence. We just if you heard about this name, using the machine learning technique and data science technique to improve your business is called as the business intelligence. So this kind of data analysis can be applied to business intelligence. Okay, the clustering. Now the most important part here is, so this I have shown over here, I want to separate the data which belongs to label number 0. So label number 0, this is what we call as Boolean filtering. We have seen that in Panda's video already. See, if I write like this, data of labels equal to 0, so these are the customer who belongs to cluster number 0. See this. Okay, if I want to find for 4th, see, these are the 4th group customers. Okay, they are extracted. If I want to find 2, these are the 2nd group customers, they are separated, correct? And I want to save this data into a file. Let's see this. So data of labels, this is a data frame, and I will be converting to 2 CSV. 2 CSV will convert this data frame into CSV format, and what's the file name? 0.csv. So if I run this, 0 customers data is stored inside the 0.csv. If I go to current working, yes, this is what we have. check it out. Okay, so customers are separated. These are the zero group customers. Check this. Almost 81 customers are present, which belongs to group number 0. Done. So values are separated based on the similarity notions. We have identified them, and the clusters are perfectly formed with the help of this particular mechanism of K-means clustering. Okay, one more method I'll show. Let's have the predictions. Okay, now clustering is also having a prediction. So prediction can be done, but now how it is done? Now when new customer comes into the file, I want to find in which particular class, which particular group that customer will go. So let's define a customer which contains like annual income and spending score. Okay, 45 and 78. Okay, so we have the object CLS, and we are having the predict function here with the help of the predict function, predict CLS. So in which group it should go, that will be predicted by this particular method. Sorry, what's the problem here? Okay, float argument must be passed, not KMeans string or a number. Okay, so if you see this in predict operations, see what I have done. When you have done the predictions, this kind of error may occur. So you just can check X parameter which is passed over here, the input that we are having in X, where the X given there, check it out, this one, X dot head. So when you want to do the predictions, the data should be again available in the same format. So float argument must be a string or a number, not K-means. Okay, so that's what we can make use of, and let's use customer here. Check it. Yeah, it is 1. So this is group number 1, correct? See, it's belonging to group number 1. Now if I make it somewhat different, 15 and 78, still 1. Okay, if I make this one as 12, this is 3, correct? If I make it 75 and 12, it is 4, correct? So in this way we are going to make use of the predictions of new data entry point again, which is present inside it, and clustering will be identified in which particular group it will go. So this grouping mechanism, clustering mechanism, is used regularly to separate your data, create the clusters, and use this for further processing, so that patterns are identified and we are going to make the group within the respective data. That's what we call as the K-means clustering algorithms, and this algorithm is unsupervised learning, as we have seen. So whenever required to create the groups of it, make sure that K-means clustering is there for you. Thank you. Thanks a lot.